Hey guys, it's me, Miss Mills, and welcome to Miss Mills Math Time. The whole point of this video is to talk about identifying functions. So this video is going to go along with identifying your functions notes. So that means whenever I'm done with this video, I'm going to put it on this last slide right here where you can click on the link and watch this video, or you can watch the video directly on the notes. It's up to you. But regardless, I feel kind of weird because I'm talking about you clicking a link that doesn't exist yet because I'm currently creating the video that the link would go along with. It's weird. I love it. All right, so let's talk about identifying functions. So what this basically is you're going to be able to look at a table, a set of ordered pairs, a graph, or an equation, and figure out if it's a function or not. Well, in order to do that, we need to figure out, well, what is a function? Well, guys, y'all came to the right video because I can tell you exactly what that is. On the next slide, I'll tell you exactly what that is. It is a rule that assigns each input with exactly one output. So that basically means that each x value is going to be associated with only one y value, okay? And I also wanted to say something as well. I'm going to be using a lot of words interchangeably in this, so I want to make something very, very clear. Input is the same as x value, which is the same as saying domain. Your x's are always going to be your domain as well as your input, okay? Now, your output is always going to be your y value. That's also known as range. So sometimes I will say range, sometimes I'll say y value, sometimes I'll say output. It all means the same thing, okay, guys? So y'all need to be able to get used to those key vocab words so you can start making connections and knowing what it means. I don't want you to get confused. So again, an input is the same as your x value, which is the same as your domain. Your output is the same as your y value, which is the same as your range, okay? Again, I'll be using that somewhat interchangeably throughout this unit. So again, a function is a rule that assigns one input, so one x value, with exactly one output, which is your y value. So let's talk about that. Let's look at some examples. Let's look at identifying functions on tables and ordered pairs. My bad. Let's talk about identifying functions on tables and ordered pairs. So again, each input has exactly one output. So what that means is when you're looking at a table like this one right here, what you need to look at is your x values. So let me highlight those real quick. Here are your x values, okay? As you can see, each input has exactly only one output. -2 has only one output, that's 7. -1 only has one output, that's 1. 0 has one output, that's -1. 1 has one output, that's 1. And 2 has only one output, that is 7, okay? This would, in fact, be a function because all of your x values are different numbers. There is never a number that repeats itself that has the same or has a different y value. Okay, so each input has only one output. So you're going to start making connections and patterns. I will say that your y values can sometimes be the same number and it'll still be a function. It's only the x values that you need to look at. They can't be the same number and have a different output. Okay, so again, each input up here has exactly one output down here. Okay, so this is a function. Let's look at these ordered pairs real quick. I'm going to move me over here. Okay, look at these real quick. This is not going to be a function, and here's why. I kind of made it where you can see it better by changing the colors up, but if you look, -2 is an x value, okay? It's an input, it's a domain, and -2 shows up twice in this set of ordered pairs. And if you notice, -2 has two different outputs. It has 1 and -8. Since -2, which is an input, has two different outputs, 1 and 8, it's not a function. The only way this would be a function is if -2 only had one output. But since it has two different outputs, it is not a function. Okay? So this would be an example of not a function because -2 has two different outputs. If y'all have any questions about that, make sure you message me so I can help out and explain that better. But we're going to move on to functions on graphs. So Identifying a function on a graph is actually pretty easy because there is this beautiful thing called the vertical line test. And the vertical line test basically means is if you draw a vertical line down on a graph, it can only intersect one part of that line at any given time. If it intersects two different points on a line at any given time, it is not a function. So let's do an example real quick. I have a vertical line right here. It's blue. I'm going to use it on this graph right here. So, all right, so I'm moving the line, As I'm moving it, I'm watching it. And I'm noticing that no matter where I put this vertical line, it only touches one part of the line at any given time. Never does it touch two parts of the line. Therefore, this graph is a function. But this graph over here, if I do the exact same thing, I'm moving it, there you go. Already does this vertical line touch a spot on two different points on the line. It touches right here and right here. And because of that, it is already not a function. But even if you move the line down even more, no matter where you pretty much put it, it's going to intersect two different points on that line. Therefore, this can't be a function. Okay, so make sure you practice that this week and make sure you understand, the vertical line can only touch one spot on that line. If it doesn't do that, if it touches more than one spot, it is not a function, okay? The next two slides, I kind of talk about that again. I put the line in different spots on this graph right here. No matter what, it touches only one spot on the line. Therefore, this is a function, okay? But the second one, same thing. No matter where I put the line, honestly, it touches two different spots on that line. See, I have the little red dots that show you two different spots where it touches. Therefore, this is not a function. It can only touch one time. Let's talk about equations. It's the same rule, only one input or an input can only have one output. So, the way you can figure out if an equation is a function or not is put some points into the equation and figure out if each output is the same or if it's different. So, for example, let's look at this first equation right here. We have y equals x squared. What we need to do is we need to create a table. And here's this table right here. I've already created it for you. And I put some negative numbers as well as some positive numbers in there too. That's always really important. And what I'm going to do is I'm going to, because these are all x's, I can substitute this x, -2, into this x right here and solve for y. So -2 squared is going to give us 4. And on the next slide, I do it all for you here. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And I put the answers on the output, the output, sorry, wow, that was weird. The output part of the table, so I was able to fill it out. And once I have it in the table, I can notice that no matter what input I have, I only am going to have one output with that input. So again, the only way this is going to not be a function is if your x values, like -2, if -2 had two different outputs, so if it was like 4 and -4, that would not be a function. But this case, it will be a function. But you can do it another way too. Once you fill out your table, you have ordered pairs. And once you have your ordered pairs, like these right here, I put the table right here, the one you see on there, and I put the ordered pairs that go along with it. So -2 and 4, I put that ordered pair right here, okay? The -1 and 1, I put that here. Sorry, I'm struggling. 0, 0, put that here. You have your ordered pairs. You can put them on the table, and then you can connect the dots and make your line on the graph. And once you make your line on that graph, you can use the vertical line test to see if it is a function. In this case, it is going to be a function, okay? Because again, if I move this blue line across the graph, no matter where I put it, it is only going to cross the line only one time at any given point. Therefore, this is going to be a function. But let's look at an example of an equation that won't be a function, okay? So let me do something real quick. I already know this isn't going to work, so I got to redo it. 8089. Okay, let me erase some stuff. So an example of an equation that's not going to be a function is, let's look at, wow, is it not gonna, did it freeze on me? Can I? There we go. Okay, let's look at this equation right here. We have y squared equals x. Guys, what that basically means is that your y is going to have two different values for the same x. So let's look at an example real quick. Let's say x is 4. If x is 4, that means that y is going to be negative and positive 2, because negative 2 squared and 2 squared both equal 4. So that means two different inputs, or that means one input would have two different outputs, and therefore it's not going to be a function. And guys, I'm going to give you a hint. Anytime you see y squared on the equation, it is never going to be a function, okay? So I'm just going to go ahead and tell you, if you look at an equation and it ever has y squared, so right here and right here, it will never be a function, okay? But x squared, yeah, it will be a function because each x value will only have one y value. But when you see that y squared, it's never going to be a function. Guys, if y'all have any questions, make sure that you message me on Google Classroom or when you're in school or anything like that. I'm always happy to help. I will see y'all later. I'm really happy to have y'all back at school. Y'all are awesome and y'all make me laugh. And honestly, y'all make my day every single day. So I'm really glad that y'all are back at school. Everybody else, y'all have a wonderful week. And again, if you have any questions, make sure you ask me. Goodbye. And goodbye.